Hello, welcome once again to Mathematics Meal, a lovely program that is designed for all lovely and wonderful people just like you. Today on Mathematics Meal, we want to consider the part 6 of what? SURD. And in part 6 of SURD, we'll be looking at multiplication of SURD. Precisely, we'll be looking at multiplication of monomial SURDs. You'll remember that when we started SURD, we said that SURDs can be monomial or what? Binomial. So in this aspect of multiplication of SURD, our business will be on multiplication of monomial SURD. Please, there is need for you to subscribe to our YouTube channel and make sure that you follow us on Facebook. Thank you. Now let's get down to business. Right. Okay. We know that monomial SURDs are SURDs that contain just single terms. Like we have 3 is a monomial SURD, 2 root 5 monomial SURDs. So when we have SURDs in this form, we say they are monomial SURD. Part 1 of SURD handled the concept of monomial SURD and also the concept of binomial SURD. Just watch that video so that you will know more about monomial SURD and binomial SURD. So our interest is on multiplication of monomial SURD. So how do we multiply monomial SURD? You know, in mathematics, if you don't know how, it becomes a problem. So multiplication of monomial SURD. So how do we multiply monomial SURD? So to multiply monomial SURD, we take these steps. First, take note of the SURDs. Okay, to multiply the whole numbers and multiply the radicals. Combine the two products using multiplication. Then simplify to obtain your answer. Just 3 simple steps. Take note of the SURDs, multiply the whole numbers, and then multiply the radicals. Then combine the two products using multiplication. Then simplify to obtain your answer. But quickly, let's just note this. The first thing we need to note, very important. We can note that when a radical multiplies itself, where the answer or the result will be equal to the number in the radical. Or to the number in the radical. Thus, if we have square root of 2 times square root of 2 will just give me what? 2. And square root of 5 times square root of 5 is just 5. So when a number, a radical multiply itself, we are going to have the number in that what? Radical. Okay, that's first. Then the second thing we need to note, let's call this the first note. And the second thing we need to note is that in some cases, we need to reduce large numbers into smaller numbers before multiplication. So in some cases, when you have large numbers and you want to actually multiply, you split, you reduce the large number into smaller numbers before multiplication, so that you will not have numbers that are too large that you find it difficult to express in basic form. Yeah. So there is need for you to take note of this. When we return, we are going to start looking at examples as far as multiplication of sorts is concerned. So don't go too far, because we'll be back to feed you on multiplication of monomial sort. Just take this short break as we relax. Thank you and God bless you. Alright, welcome back. I believe that you enjoy that short break just to help you relax. Alright, we have to continue with the concept of multiplication of monomial sort. Remember that we just gave this step before we went on that short break. So let's apply these steps in multiplication of this monomial sort. Remember, I've already asked you to look at the first video, sort part 1, so that you understand what we mean by monomial sort. We have already said that monomial sort are sort that contain just one term. Once you have sorts in this form, they are monomial sorts. So let's multiply. Let's do this example 1. Example 1. We are asked to multiply square root of 5 times square root of 10. Okay? So take note of the sorts. We have taken note of this sort. Multiply the whole numbers and multiply the radicals. Now here we don't have whole numbers. What we have are just the radicals. So the first aspect of step 2 will be ignored because we don't have whole numbers here. So we just multiply the radicals. Remember our basic law in our second video, part 2 of sort. We gave this basic law that if A and B are whole numbers, and they are not zero anyway, they are whole numbers, positive whole numbers. We say that when we have positive integers, that's whole numbers. When we have square root of A times square root of B, we can have it as square root of A times B. So when they are separate, we can bring them together under a common square root sign. So that's what we have here. So we can transform this from this form to this form. So that's what we mean by applying the basic law in multiplication of the radicals. So let's multiply these two. So we have 5 times 10. Okay? If we multiply this, we're going to have square root of 50. Now in step 3, they say combine the two products using multiplication, then simplify to obtain your answer. The two products we are talking about is the product of the whole numbers and the product of the what? Of the radicals. In this case, we don't have product of the whole numbers. So the only remaining product is the product of the what? Radicals. So we now say simplify, then simplify to obtain your what? Your answer. So let's simplify. How do we simplify? We need to express this sort in basic what? In basic form. And you remember, this can be written as 25 times 2, which is square root of 25 times square root of 2. What is square root of 25? 5. And 5 times 2 will give you 5 root 2. That's here. 5 times square root of 2. That will give me 5 root 2. Wow. So, that's multiplication of square root of 5 times square root of 10. We're going to have square root of 5 times square root of 10 here, then square root of 15, then square root of 25, separating this because we are trying to express it in basic form. That's what we say here. Combine the products using multiplication, but because we don't have product of the whole number, so we just simplify to obtain our answer by expressing this square root of 50 in basic what? In basic form. Okay? That's beautiful. So let's take another question, example 2 this time around. Let's take a second question on that. Example 2. We have simplify. take a quick one. Simplify 3 root 3 times 2 root 2. Oh, that's nice. 3 root 3 times 2 root 2. In this case now, we have whole numbers, and then we have what? Radicals. So we can handle this. Take note of the sort. That's what we are asked to do in our first step. So 3 root 3 times 2 root 2. We have taken note of this sort. They said multiply the whole numbers and then multiply the radicals. Where are the whole numbers? 3 and 2. So 3 times 2 times, where are the radicals? Root 3 and root 2. That is square root of this times this. 3 times 2 is what? 6. 3 times 2 here is 6. So we simplify to obtain our answer. So by combining the words product. This is the product of the whole number, and this is the product of the what? Of the radicals. If you combine the two products, you have 6 root 6. It says simplify to obtain the answer. We cannot simplify this any further, so we leave the answer in this form. So you see, multiplication of SURD of monomial SURD precisely is very, very, very simple. Just very simple. Very simple. Okay? We take another example. Yes, our business is to feed you mathematically. That's our business. To feed you mathematically until you are no longer mathematically hungry. Yeah. That's our duty, and also our duty. So let's take this. We have square root of, simplify square root of 15 times square root of 12. Square root of 15 times square root of 12. Okay? Let's solve. Square root of 15 times square root of 12. We don't have whole numbers, yeah? So we can just combine this, multiply the radicals. We'll have a large number, but let's try that. We're going to have a square root of 15 times 12. If you multiply this, we're going to have square root of 180. We took note of the SURD. There is no whole number to multiply, so we multiply the what? The radicals. Yeah. There's nothing to combine, so we just simplify the result. Let's express square root of 180 in basic form. That will give me square root of 36 times 5. You see why the previous videos are very, very important. Yeah. So we have this, which is square root of 36 times what? Square root of 5. What is square root of 36? 6 times square root of 5. When you multiply this, you have 6 root what? 6 root 5. So that's the steps. We have applied these steps in solving this problem. So we multiply the radicals because we don't have what? Whole numbers here. In the previous example, we saw that we had no whole numbers. So that's why we multiply the whole numbers also. So, but here, we don't have whole numbers, so we multiply the radicals, and we have this large number. Nothing to combine. Combine the two products. That's the product of whole number and the what? Radical. But we don't have whole numbers, so we will not be combining the products. The only product we have is the product of the radical. So all we need to do is to now simplify to obtain our answer. The number here is large, we express it in basic form to get the answer. Alternatively, one can still decide to split these numbers, reduce them to smaller numbers, and you still arrive at the same what? At the same answer. That's correct. You still arrive at the same answer when you reduce them to smaller numbers. Like what I pointed out here. If having a large number will be a problem to you, then one can decide, I believe you have taken note of this, one can decide to, since we have square root of 15 times square root of 12, one can decide to have this in this form, square root of 5 times square root of 3, that is square root of 15, then times square root of 12. Square root of 5 times square root of 3 times square root of 12, will give me square root of 5 times square root of 36. And 36 is a perfect square. Yeah, it's a perfect square. So we have square root of 5 times 6. And when you multiply this, you have 6 root of 5, which is the exact answer we had previously. So many ways of handling this. You can still decide again on your own to break this in this form. Square root of 15 times, express this one in basic form first. So we have square root of 4 times 3, which is square root of 15 times square root of 4 times square root of 3. Square root of 4 is 2. Square root of 15 times 2 times square root of 3. So 2 is the whole number. I can multiply the radicals. I have 2 times square root of 15 times 3, which is 2 times square root of 15 times 3 is what? 45. It's 45. So you now express 45 in basic form again. So that's quite long. If you move further, you have 2 times square root of 9 times square root of 5. Square root of 9 is 3 times 3 times square root of 5. And that will give us 6 root 5. So the most important thing is understanding the concept and your ability to apply the principles in SURD. If you just apply the principles, you will not have problem. The only one we will not accept is when you now begin to panel beat mathematics. You begin to do a lot of terrible things in order to arrive at an answer. Things that are not rational, that are not logical, things that are outside the principles. Yeah. And the moment you fail to follow the principles in mathematics, in solving an equation, then the principalities of mathematics will now begin to visit you. So if you don't want the principalities and powers of mathematics to deal with you mercilessly, you need to follow the principles of mathematics while solving problems of mathematics. So let's move on. So let's take one more question, and then we'll have our takeaway question for the day. So one more question. Question number 4. Question 4. Another simple one. Evaluate. Evaluate. Where do we have this? Okay. 3 root 2 all raised to power 3. Oh, right. We're asked to evaluate this. Evaluate 3 root 2 all raised to power what? 3. So we know what this means from your knowledge of indices. 3 root 2 all raised to power 3. It means multiply this base. This is now the base now 3 times. Multiply this 10 3 times. So this is 3 root 2 times 3 root 2 times 3 root 2. Wow. So we have whole numbers. Like here, multiply the whole numbers. So we have 3 times 3 times 3 times, multiply the what? Radicals. The radicals are what? Root 2 times root 2 times root 2. 3 times 3 times 3 will give me what? 27 times root 2 times root 2. We'll go back here. When a radical multiply itself, it will give you the number in the radical, because square root of 2 times square root of 2 will give us what? Square root of 4. And square root of 4 is just 2. So when a radical multiplies itself, it will give us the number in the radical. One can still go further to multiply all of them and express in basic form at the end. But let's handle this now. This times this will give me just 2. And we are left with what? Square root of 2. So 27 times this is what? 54. Times this will now give me 54 root 2. Wow. So far so good. So far so good. So I believe with this, you can handle the multiplication of all monomial what? All monomial sorts. Alright. Without taking much time, here is our takeaway question. Let's have that. Let's have that. Let's have that. Okay. Take away questions. Oh, the other time we had this thing. So let's take ice cream today. Let's take ice cream again. We just want to cool it down. Yeah, want to cool it down. Simplify the following. Simplify the following. Number 1. Okay. Square root of 20 times square root of 3 times square root of 2. 2. Square root of 5 times square root of 6 times square root of 5. 3. Square root of 32 times square root of 12. And 4. We have 2 root 3 times 12 root 15 times 3 root 5. Then finally, number 5, we have 2 root 3 always to power 4. Okay, so let's handle these questions, and then in our next video our interest will be on multiplication of binomial sum. Thank you for watching our videos. Remember, there is need for you to share our videos, leave a comment for us, solve this question, send the answer to us through our WhatsApp or to our messenger or to our Facebook page, or maybe through any means that is suitable for you. But just make sure you solve the problem and get back to us. We want to see you improve on a daily basis as far as mathematics is concerned. Keep watching Mathematics Meal, because that's the only place you will get a healthy food that will keep you healthy mathematically. I love you so much, and I know that you love me. Thank you, and God bless you.